This is the question, minimum deletions to make string case special, which was featured in Weekly Contest 389. So the description reads, we're given a string word and integer k. We consider a word to be case special if the frequency of word I minus the frequency of word j for all indices I and j in the string are less than or equal to the value k that we were given. So it's a little wordy. What this is really saying is that if we take the frequency of any characters, let's just say A and B, if we subtract these both need to be less than or equal to k. So we just need to make sure basically that for any frequencies of characters that we have in this string, we need to make sure it's less than or equal to this k value. So basically we want to return the minimum number of characters we need to delete in order to make this word case special. And this is one of the examples given. So in this case, it takes 2 character deletions. We can make it word 2 special by deleting 1 occurrence of A and 1 occurrence of D. And that makes the word become equal to this string where all of these frequencies fall within that condition. So you can see frequency B is 2, frequency C is 3, and frequency D is 4. And these all meet these conditions. So if we were to do 2 minus 4, absolute value, that equals 2. That's less than or equal to our k value. If we do 3 minus 4, that's 1, less than or equal to k. So as you can see, this meets our condition. So let's look at this example in a bit more detail and see how we can actually solve this. So, given that this question has to do with character frequencies, a good first step is to actually generate these frequencies and just see what we actually have. So going through, we'll see we have 1A right here. If you look at the B's, you'll see we have 1, 2. If you look at C's, we have 1, 2, 3 C's. And if you look at D, we'll have 1, 2, 3, 4, 5 D's. So k is 2 for this problem. So what that means is if we look at these values, they all have to be within k of each other's frequencies. So as you can see here, this 1 and 5 violates this condition already, because if we do 5 minus 1, that equals 4. If we do 1 minus 5, absolute value, that also equals 4. So clearly we need to do some deletions. And one interesting thing you can take from this is that it doesn't really matter which order we do it in. If we just do the larger one minus a smaller frequency, it makes it simpler because we'll always have that positive value. We don't even need to worry about doing absolute value or anything like that. So what if we were to find a way to actually compare smaller and larger values? So we could put these into an array that's sorted, which allows us to do something like this. So from here, what you can kind of do is almost a 2-pointer approach. So what if we were to consider the smallest element as I, and then this largest element as j. And basically what we're doing is we're going to shrink this j value until our condition for k is met. So here you can see 5 minus 1 is 4. This is greater than or equal to k. So we have to move our j down, right? And here we'll see 3 minus 1. Sorry, it should be minus 3 minus 1 equals 2. So this falls within our condition. And we know that at this point, as we keep decrementing j, we won't have any more deletions, right? Everything from this point on, if we keep going to the left, will be smaller than or equal to 3. And we see we don't have to do any deletions for this, so we can kind of stop here. So what does this 4 tell us? So for here, what we can do is 5 minus 1 which is our I value here, plus 2, which is our k value. So if we do j minus I plus k, that will give us the number of deletions that we need to make these fall in line with each other. So you can see if we do 5 minus 3, which is the value we got here, this will equal 2, and these will be in line with each other. So is this the smallest value? Not necessarily. So now what we can do is go to our next I value. So if we were to start again with our I here and our j here, we can kind of do the same procedure. But one thing we have to do here is we have to think about what happened with this value 1. Well, we can't just ignore it, right? Basically what we have to do is say, if we're kind of using this 2 as our smallest value, we have to consider that we've deleted this 1, right? And that's an option. We can just completely remove all the occurrences of a character, and it's almost like it doesn't even exist at that point, right? So now what we can say is that we're starting with 1 as our base case, saying like, we've already deleted 1, now let's see if we try to get everything in line with this 2, how many deletions we have to do. So here we could see 5 minus 2 is 3. That's greater than our k value. So we need to do some deletions, right? So we can do 5 minus our I value, which is 2, plus 2, which equals out to 1. So we can do another one here. Then we can shrink our j, but as you can see, this is smaller than or equal to k, so there's no point in really continuing. And basically that's the logic of this algorithm. We just want to kind of basically try all possibilities of I, right? And say, we want to try and make all the values larger than this in line with our condition relating to k. And as we increment our I, we have to consider that these previous values are just completely deleted and count those in our minimum number of deletions. So here this actually is the optimal answer, 2, and we found it. So some people might be thinking, is this going to pass? The constraints are pretty high. I think it's like 10 to the 5 number of elements in our string. But what we have to consider is this array will be at most 26 characters, right? And the reason is we're actually counting the frequency of these characters, and there can be at most 26 characters in this string. So even if our string was 10,000 characters, at the end, we're going to be counting all those, and there'll be a max 26 values that we'll be looking over. So we can easily do a nested loop on an array of 26 values. What that basically means is that what we're doing is O of n initially to get those frequencies, and then we're doing plus 26 times 26. This is representing that nested iteration through the counts of frequencies. Eventually this cancels out and just makes our final time complexity O of n. So let's hop over into the code, and hopefully this makes a bit more sense. So here you can see we're starting off by just grabbing the counts of all the characters that appear in this word. Then we put these into an array and just sort those. So this will now be a sorted array where each element represents the frequency of a certain character. We don't really care about which character is which, and we really don't even know in this array. All we're considering really is the actual number of times that a character may occur, regardless of what the character is. So now we keep track of our minimum deletions, which will be our final answer, and total deletions. So this total deletions, what this will help us do is consider that case we talked about previously, where as we're moving our I value to the right, we have to consider that everything to the left has just been completely removed. And as we're going through and considering all these different conditions, we need to keep track of those. So what we do is we're going to go through all of our I values in the array, and our deletions for this iteration we're going to set to total deletions. And this is going to help us keep track of all the other characters previously that have been removed. So then we start another loop where we start at the end, and if at any point we hit the condition where counts j minus counts I is less than or equal to k, we know there's no point in continuing, so we can just break and continue with the next iteration. Otherwise, we know we need to delete some number of characters, and we can use the algorithm or equation that we discussed previously, where we take counts j and we subtract counts I plus k to get that. At the end, we're going to set our minimum deletions to the minimum of the deletions we've seen in this iteration or some previous answer that we found. And then we want to increment our total deletions by counts I. And like I said, this is what's helping us keep track of previous characters that we've completely eliminated from the array. Then at the end, we just return min deletions. So let's submit and make sure this works. So as you can see, passes all test cases. And yep, hopefully this was helpful. And thank you for watching.